Welcome Organics to this new module. Hope you're doing well. The world is really exciting, isn't it? It's exciting in its all form. Either you talk about the abiotics or the biotics. There are also countless forms of life on this earth as well as in the sea. They are constantly dying and vanishing. But human life is very rare, is special and unique. The nature has gifted the human being a lot. The Homo sapiens alone has the power to think, to reason, and to understand the world around, and has the sense to search for happiness, peace, and contentment. And because of this deep sense of reasoning and curiosity, the humans have always been eager about the world around them. The moon, with its changing shapes every day, the sun with one color in the morning, the other in the afternoon, and the other in the evening. The volcanoes, the rainbows, has fascinated human beings since time immemorial. The early humans started a careful observation of these interesting natural phenomena, and they started looking for some particular patterns and relations in their experiments. And in course of time, the keen sense of observation of humans and their interest in these natural things led to the modern science and technology. I think most of us know that science, the word science, originates from the Latin word scientia, which means to know. The Sanskrit word Bigyan, or the Hindi, we can say, or the Hindi word Bigyan means the same. Bigyan means Bises Gyan, means special knowledge, having a special knowledge about the world. There are different names for this particular word science in different languages, but we have nothing to do with the names because language is just a medium now. What is the knowledge we have is what matters the most. So let us go forward, and the next question what arises is that what is this science, and what is this science, and what is this so-called scientific method? Science is a systematized and well-organized body of knowledge that is based on experimental observation. NCERT says that science is a systematic attempt to understand natural phenomena in as much detail and depth as possible and use the knowledge so gained to predict, modify, and control phenomena. I think this definition is very accurate because what we really do is we observe some phenomena, we crunch data from our observation, and we give some models and postulates. And after that, we build some tools which are the applications, which is based on the application of those models. And with the help of these tools, we start interacting with nature in the more fundamental way. So let's move ahead and see what are these hypotheses, axioms, and model, and what is the importance of them in science and especially physics. The one very thing is that one should not think that everything can be proved with physics and mathematics. It's not true. All physics and also mathematics is based on assumption, each of which is variously called as hypotheses, axioms, or models. Let us take an example, a very basic example, I think, which everyone takes. The universal law of gravitation, which is proposed by Sir Isaac Newton, is just an assumption or hypothesis. What the law says? The law says that every object in the universe attracts other objects with a force which is directly proportional to the product of their masses inversely proportional to the square of distance between them. So, what we learn is that hypothesis is just a supposition without assuming that it is true. It would not be fair to ask anybody to prove the laws of gravitation or Newton's law of motion because it cannot be proved. It can be verified and substantiated by experiments and observations. Now let us come to axiom. An axiom is a self-evident truth. And what is model? A model is a theory proposed to explain observed phenomena. Things are getting complex. Why? We need not to worry about these all things at this stage because we'll come across these all things in a very deep in our further studies. So let us take an example of model. We have read about the Rutherford model for atoms. What it says is that Rutherford did an experiment, a gold foil experiment. The observation which Rutherford got from his experiment made him to propose the model of an atom. In his model, he says that the nucleus of the atom is concentrated at its center and is positively charged, and the electrons are revolving around of that positively charged nucleus. Now, Rutherford hadn't seen the atom, neither he had seen the nucleus or the electrons. But how he proposed the model? Rutherford got some data, some observation by his experiment, and he said that if we accept this model of atom, then we can prove the observation at one stroke. And that is really what happens in science, and especially physics. Einstein's special theory of relativity is also based on two postulates: the constancy of speed of electromagnetic radiation and the validity of physical laws in all inertial frame of reference. It would not be wise to ask somebody to prove that the speed of light in vacuum is constant, independent of the source or observer. And this is what happened. There are some models and hypotheses are proposed by the scientist, and if we accept those models or hypotheses, then we will able to explain the observation which we get from natural phenomena.